Hello everyone, my name is Harish and I would be talking about Cloudera Impala today, and this is my final paper for E90 Cloud Computing subject. So the agenda would be what is Cloudera Impala, why Cloudera Impala, the key features of Cloudera Impala, and the history between Cloudera Impala and Dermal, and how Cloudera Impala works with Hive, the big picture overview. We'll be talking about Impala and traditional database differences, and the installation of Cloudera Manager for creating those clusters and demonstration of queries, and finally the performance and inclusion. Alright, so what is Cloudera Impala? Cloudera Impala is an open source. It has a massive scalable parallel processing query engine which runs on Apache Hadoop. Impala enables user to issue low latency SQL queries to data stored in HDFS or HBase without requiring the data movement or data transformation. That means actually you don't need to really move the data inside Impala to run and execute those queries. You can just leave it where it is right now. Actually, if it is an HDFS, you can leave it there, and you just need to reference those queries. That's it, to run those, execute those queries. Impala is integrated to Hadoop ecosystem. It leverages the same flexible file format, data format, metadata, security as MapReduce and Apache Hive, Pig, everything shares actually. So it belongs. It's a new to Hadoop family. It is, you call it as Hadoop ecosystem. So why do people choose Impala? Impala is a reliable data warehouse to execute tasks in data analytics, monitoring, and BA actually. It performs fast interactive analytics on unstructured data. It has the ability to perform real-time data stored in Hadoop via SQL. You can use your favorite drivers, JDBC, ODBC to connect it. Traditional data warehouse, if you're coming from a traditional data warehouse application background, it doesn't have a real-time access. That means you do the data load from one area to another area, then you do like it, the data load happens once every hour or once in 2 hours or once in a day. Some of those massive data load happens once in a day actually. You don't do, and that too we do it during off hours. You don't do it during the regular business hours actually, because it will impact the system. But things will change using Impala. You don't need to really do those traditional things actually with Impala. You can just pull the data where it is. You can pull the data from the source system directly, and you can compute. You can just fetch the results set within few seconds. Today, a lot of data is in Hadoop. Practically, it doesn't make sense moving the big data. So, but it was practical to move a high. It was practical to bring a high-speed engine. Running Impala on the same cluster as MapReduce workflow, Hive, Pig. This is an advantage for Impala. So what are the key features of Cloudera Impala? Impala is an in-memory distributed SQL engine. It doesn't has a MapReduce. It has a native massive parallel processing query engine. It leverages same metadata that other Hadoop family uses, Hadoop ecosystem family uses. It connects to JDBC, ODBC driver, distributes on HDFS and HBase nodes. It has a low level latency response. That means just just click on a button, actually just get the response within few seconds. And it deploys on Hadoop clusters. You can submit queries through VWAX. It supports wide variety of file format when compared to other things in the market actually. It has a Kerberos authentication. It has a role-based authorization with Sentry, which is new. It is 100% open source. So the history. Impala was inspired by a Dermal paper back in 2010. Dermal is a scalable interactive ad hoc query system for analysis of read-only nested data. This is the basis of Google BigQuery. And I was reading somewhere actually, it fetched 1 trillion records within few seconds. And Impala is an open source, whereas Dermal is not. It's proprietary to Google. The technique that was developed was based on parallel DBMS. If you're an old-time programmer, if you have worked with DBase 3, DBase 4, Clipper, so these are DBMS, database management system. It's not relational, it is database management system. So that was the techniques used to develop Impala. And as described in 2010 paper, actually it could only do single table query. It could handle only, the Dermal could only do single table query, whereas Impala supports full set of join operations. And Impala also supports wide range of file format when you compare to terminal. So what's the difference between Impala and Hive actually? Is Impala going to replace Hive? The answer is no. The major goal is to make SQL and Hadoop operation fast, and to make use of the existing infrastructure, actually Hadoop Apache Hive infrastructure, and make use of already whatever you have with Hive. Impala keeps a stable information in MySQL or Postgres database. This is the same database where Hive uses. You call it as metastore. That means actually you don't need to create table in both places. Actually, you just need to create a table in one place. It is accessible in other in Hive as well, or you just need to create in Hive. It is accessible in Impala. If everything matches actually all the file format, there is a little bit of difference between these both. Actually, I won't be touching that. So Impala and traditional SQL actually. So there is no update or delete. You might be surprised. Yes, if you're coming from a traditional SQL background, there is no update or delete. But there is an option to, if you are looking for update or delete, actually there is an option in insert into override, which updates everything, and you can use the same option for truncating the table. And you might be surprised actually if you're from a traditional SQL background, actually insert into table A column 1 2 3 values 1 2 3. No, it is not possible. Well, you can do that. You can use what you can do is actually, if you have to do one column load, actually then you create a file, create the file, put the data in the file, and then use a load command to load into that particular table where that particular file location. It's a pain. You often construct Impala table definition and data files in some other environment and then attach it to the Impala so that you can run real-time queries. Actually, that means actually you don't need to bring the data into Impala. You can just suppose actually if it is in Hadoop ecosystem somewhere in HDFS or your HBase location, you can still run those queries. So this is a big picture here. You have the interactive SQL engine. It has a resource management storage. You have HDFS. You have a text. All these file formats, which is it has integration. Actually, it has a metadata management and support. This is another thing which I would be talking about. Cloudera Manager Services. Actually, this installation is a must for installing Cloudera Impala Hadoop family. So this is like you have this real-time queries. If you look at this picture, actually you have real-time queries. You have a certified connectors like BI, business intelligence, or extract transformation load, ETL, or relational database, or here you can see Impala over here, which has a real-time access and compute, and you have a metadata which stores all the data, and you have Yarn, Zookeeper, you have workflow management OZ, and you have MapReduce, batch computing process, MapReduce 1, 2, and you have batch processing like Hive over here, Hive Pig, and you have a RESTful API. Actually, this is the complete Hadoop ecosystem, and we would be installing these services on the clusters, on our Hadoop clusters, which we'll be creating using the Cloudera Manager services. Again, Cloudera Manager is a tool which manages all the clusters. You can do administrative services using Cloudera Manager. So the purpose of the Cloudera Manager is to install all the AWS on CDH, and the component server parameters, port restarts. You can monitor health issues. You can have a good reporting, and you can do maintenance work. Okay? So all you need is you need to choose AWS and then connect to SSH, and just using wget command you can download the bin file, and you just need to run it, and make sure you open the port 7180. Okay, in this picture actually we are installing only the Cloudera Manager now. Actually, we are not at there actually installing the other clusters. We would be doing that using the Cloudera Manager. And this is the login screen that you get once you log in, and you should use your port 7180. And again, I said actually you need to open up the port in your EC2 security services. Actually, if you use your own EC2 security service, you need to add this port. So creating Cloudera using Cloudera Manager. Now you are creating a cluster using Cloudera Manager. You have two options now. Option A is automated installation, which it chooses the latest options, latest versions of all those components, and then it installs. And option B is you can do manual installation. I chose option A, which was easier, but there were many failures because the compatibility of the operating system, and because since operating it's open source, it could fail anywhere. So, and make sure your AMI is in the same region of Cloudera Manager. You have to specify all those EC2 users, and you have to specify the group name. And right now we are installing the clusters here actually, which means actually I'm installing all those host 1, 2, 3, and we have already done this using the Cloudera Manager. I'm installing the Cloudera clusters now. Okay, it is a 10 or 20 step process, and you need to know what you have to provide the parameters. You need to use a key. It has a lot of I will cover some of those actually, and you need to provide the key, all the authentication key. You need to give all the details. Once you provide all the details over there, you can, here in my case I choose the AMI to be this one, which is CentOS AMI, and I provided my username actually, and I choose just small instance because I don't have much. I don't have my, what do you call actually, the billing amount. I am a little worried about the billing amount, so I choose only 3 instances, and I am going to install latest release of CDH4 and latest release of Impala. So once I click start installation, then next. So you get I told you actually this is a 10 or 20 step process. I just cut short and make it very very crispy actually. And once this is the final step where it has provisioned those particular, once you click the previous step actually, then it will start provisioning the allocating the creating those AWS for you. And once it creates and installs all the necessary softwares in those machines, the Cloudera Manager does a beautiful job actually. But you may not be successful every time actually. You might, if you look at this here, it is successful, but if you are not successful, then it will provide a red, this one saying that rollback or uninstall actually. You can keep on trying actually. Probably I would have tried 5 or 10 times for each installation. Sometimes you will be successful, sometimes you may not be. If you're not successful, you need to go back. There will be a back button over here actually. Then you go back and it rolls back all the clusters that it created for you. You don't need to really log into AWS and cancel all those clusters, because using the Cloudera Manager automatically deletes the clusters actually, terminates those clusters if you are not successful. But if you are successful, click continue button. It will give you the version summary of what installation it did, like Impala, Yarn, HDFS, Snoop, all those MapReduce, HBase, OZ, Zookeeper, Who, all this was installed. Hadoop Hive was installed, and it will, once you click next actually on the continue button, it will start all those services actually. If you can see actually, it is Impala services started, and like Hive services started, MapReduce is started, HBase is started. All those out of 22 steps services it starts. Right? Once this is done, then you have successfully installed all your clusters, and then is here. This is the login of Cloudera Manager. You can see you can do a lot of things here. Actually, you can do the administration. You can pull out the reports. You can pull out the reports time based actually. That means what was the situation in today afternoon 12 o'clock. You can just pull the bar and see how was it looking. You can do audits. You can do diagnosis, and you can do a lot of activities actually. You can click on those one of those server, and then you can know the details here. If you could see actually a lot of health issues, and there are configuration issues wherein you can resolve it actually, which if you look at my original document actually, I have resolved those issues. So now after this installation, what is the main step that you need to do is actually here. If you need to click on one of HDFS or Impala source actually, then you need to note down the what do you call wait a minute. Okay, you need to note down the name node actually. Name node is your master node. The master node is the one you connect SSH in. Okay, so once you note down the master node, you can go to your AWS console and pick out what is the DNS address, and you can log in using SSH. And once you log in, actually, okay, so now the query execution part, I picked up a database which has sample database which has data of books, customers, and transaction, and I extracted to a location actually called user project work, and I ran this query. It took 6.57 seconds in Impala and 101.38 seconds in Hive actually, which was really fast. I could see the difference. And since Hive is a little bit slower because it does all this map reduce, all these bad jobs actually. So the next query was a little bit complex. This was a use case like a state-wise yearly transaction. How much revenue did I get every year in each state? Actually, this is a good BA report, and it returned 700 rows actually, and it returned within 75.96 seconds in Impala, and whereas Hive returned 1368 seconds, which was really slow. But the results it was returned like it was a little bit slow, yeah, but yeah, the results were the same. And how much faster it is? Is it really faster? Well, it all depends upon hardware configuration. Hive takes a lot of CPU load, whereas Impala is observed to take a lot of I/O bandwidth. Typically, if you don't have a much I/O speed, actually, then you can see the performance gain only 3 or 4 times. If the queries are a little bit complex, and if we just only one join, then you can see the performance of 7 to 45 times. And if the query, if the availability of main memory, if the table is available in cache, then you can see massive difference actually, like 20 to 90 times. And you know one more thing actually, the recommended node memory for Impala is 128 gigabyte. I was surprised. And what are the limitations here? Impala daemon is only focused on speed now. Speed. Okay, Impala is missing some functionality of which MapReduce has, like data deletion, full text search, indexing, custom serialization, deserialization, querying of streaming data. There is no fault tolerance. If any node fails, boom, it reruns the query again actually. So, and the conclusion, the test on the above queries with Cloudera Impala is always provides high query performance and retains a familiar secure experience. Impala and Hive fetch the data stored in HDFS as a part of testing. Tables created in Impala were accessible in Hive, and when compared to traditional data warehouse application, the data load was very fast, super fast, I could say. And I think this would be a game changer for big data analytics actually, and the way the ETL performs right now. That's it. Thank you. Thanks a lot.